Worked solutions for June 2023, higher tier, paper 2. Question 1, write 30 to 12 in the form n to 1. To do this, we need to make sure that the second number becomes 1, so we have to divide both numbers by 12. So 30 divided by 12, if we work that out, comes to a value of 2.5. And then 12 divided by 12 is of course 1. Now we then just need to make sure we fill in the 2.5 in our answer line here. Question 2. 4 consecutive triangular numbers are as follows: 6, 10, 15, 21. Write down the next triangular number. Now you should be able to see quite quickly the pattern of the numbers: add 4, add 5, pattern of the numbers in the sequence. Add 5 to get from 10 to 15, add 6 to get from 15 to 21. So the next triangular number will be generated by adding 7 to 21, which of course gives us an answer of 28. Question 3, write down the reciprocal of 4/7. So a lot of you will think of the idea of a reciprocal as flipping the fraction over, so it becomes 7 over 4. In reality, what's happening is when you take the reciprocal, you do 1 divided by that value. So you're doing 1 divided by 4/7, or 1 multiplied by 7 over 4, which if you think of it as 1 over 1 multiplied by 7 over 4 is just 7 over 4. Question 4. The price of a toy increases by 12.5% to £19.53. Work out the original price of the toy. So this is a reverse percentage question. If we call the original price of the toy X, the original price is increased by 12.5%. Now, if you're increasing by 12.5%, you're multiplying by a percentage multiplier of 1.125. Now, this is because an increase of 12.5% means you're now working out 100%, which is the original price of the toy, plus this extra 12.5%, which means you have 112.5%, which means your multiplier is 1.125. Now, when you increase by the 12.5%, you get £19.53. So X is going to equal £19.53 divided by 1.125. And if we input that into the calculator, we get an answer of £17.36, which we'll fill in on the answer line here, £17.36. Question 5. Jess saves 2p, 5p and 10p coins. She has 45 10p coins, 8 times as many 2p coins as 10p coins, and £17.70 in total. Work out the total value of the 2p coins as a ratio with the total value of the 5p coins. So that's not the number of 2p coins to the number of 5p coins, it's the total in 2p's to the total in 5p's. So let's start this off step by step. So if we have 45 10p coins, that means we have 450 pence, or £4.50. Now, if we have 8 times as many 2p coins as 10p coins, that means we have 8 times 45 2p coins. So 8 multiplied by 45 gives us 360. So that's 360 2p coins. But what's that equal to? Well, that's 360 multiplied by 2, which is 720 pence, or £7.20. So that, I'm going to remember that because that's the amount I have in 2p coins. Now, if I have this much in 10p coins and this much in 2p coins, I can now work out how much I have left in 5p coins, because I have £17.70 in total. So I'm going to do £17.70, subtract £4.50, subtract £7.20, and that will tell me how much I have in my 5p coins. And that comes to £6. in 5p coins. So to get my ratio, remember, we need to do the total value of 2p coins, which is £7.20, let's make that a little bit clearer, £7.20, in a ratio with the total value of the 5p coins, which is £6. And we then need to simplify this because the question says give your answer in its simplest form, which means we don't want to have this in this decimalised form of 7.2. Now, if you think about your 12 times table, both 72 and 60 are divisible by 12, so there are going to be ways of simplifying this down. So if you actually divide both of these by 1.2, £7.20 divides by 1.2 to become 6, and 6 divides by 1.2 to become 5. And that's our simplest form. Now, you might take more steps to get there, you might keep halving them, you might do different sorts of things to get down to that, but 6 to 5 is your final correct answer. Question 6, part of a regular polygon is shown. Assume that the polygon is an octagon, so that means it has 8 sides. Work out the size of an exterior angle. Now, there are lots of ways of doing this. Some of you memorise these complex formulae for interior and exterior angles, but the easiest way to do this is to know the fact that the total of the exterior angles is always 360 degrees, and that's for any polygon. If we want to then work out the size of an exterior angle, well, divide the total of the exterior angles by the number of sides, 360 divided by 8, and that will give you the correct answer of 45 degrees. There are other ways of getting to that, but it's a 2-mark question. It's only going to involve a simple calculation, like 360 divided by 8. Now, part B. In fact, the polygon has more sides than an octagon. What does this mean about the size of an exterior angle? Well, that means that to work out the exterior angle, you're doing 360 divided by a larger number than 8. Now, if you're dividing by a larger number, then you're going to get a smaller answer than you did in part A. So the correct answer is it's less than the answer to part A. Question 7. We have an ordinary fair 6-sided dice rolled and the fair spinner shown is spun. The score is the dice number substituted into the spinner expression. Complete the table to show all of the possible scores. So X is basically numbers 1 to 6 from the dice, and you've then got to fill in these numbers in the table. So 2X simply means we are doubling the X values. 3X simply means we are multiplying the X values by 3. Now, this is a sort of question it's very easy to make a silly mistake on and then lose potentially 2 marks, so be careful with your values and your calculations. X squared simply means we square the X values, 1, 4, 9, 16, 25, 36. 7 part B. A player wins the game if their score is 10 or more. Work out the probability that they win the game. Now, if you look back at the sample space diagram on the previous page, there are 18 possible outcomes, some of which are the same number, but there are 18 possible outcomes. Now, if you count up how many of these result in a score of 10 or more, well, you've got 10, 12, 12, 15, 18, 16, 25 and 36. So that is a total of 8 outcomes out of 18. So the answer is 8/18ths, or that simplifies down to 4/9. Do not convert that into a percentage and then round it. There's no value in converting this into a decimal or percentage. 4/9 is a nice exact value. Leave it at that. Don't risk losing a mark by converting this weirdly to 44.4% or 0.4 recurring. Leave it as 4/9. 7 part C, the game is played 711 times. Estimate the number of games that are won. So we know the probability of winning is 4/9. And in 711 games, we're making the expected calculation that 4/9 of these will be won. So we need to do 711 multiplied by 4/9, and that comes to 360. Question 8 is a question about equating or comparing coefficients. So on the left-hand side, we have a minus 3x squared, and that's equivalent to 5x squared on the right-hand side. So that tells us that a minus 3 has got to equal 5, because this triple equal sign tells us this is an identity, and the left-hand side has got to be identically equal to the right-hand side. So the coefficient or the multiplier of x squared on the left-hand side has got to equal the coefficient or the multiplier of x squared on the right-hand side. So if a minus 3 equals 5, a is equal to 5. And then we'll do the same with the other part, which is this constant here, 2b, and that's got to equal 12. So that tells me that 2b equals 12, which gives me b equals 6, very simply. Question 9. ABCD is a parallelogram. AD and BC are horizontal and each has length 5 centimetres. The diagonals of ABCD cross at E. Work out the two possible pairs of coordinates of E. So the only way to do this question sensibly is to actually draw out possible parallelograms. So we know that AD and BC are horizontal and each has length 5 centimetres, and this is a 5 centimetre grid. So if we count along 1, 2, 3, 4, 5, well, that gives me a possible position of D, and then 1, 2, 3, 4, 5, that gives me a possible position of C. And then if I use some red lines to draw in my parallelogram, use a ruler when you do this, there we go, and then we know the diagonals cross at E. So the diagonals, if we draw them in, are going to cross at this point here, which is 4, 6. So one possibility is 4, 6. Now, D and C do not have to be on the right-hand side. They could have been on the left-hand side. So if we go left 5 units from A, 1, 2, 3, 4, 5, that's another possible position for D. And if we go left 5 units from B, 1, 2, 3, 4, 5, that's the other possible position of C. And if we then join up those lines, this is what our parallelogram could look like. Now, if we then join the diagonals again this time, we're going to see, and again, if you do this with a ruler, you'll get this absolutely spot on. They cross at this point here, which is -1, 6, and these are the two positions of E. But I would not have been able to do that very easily without drawing this on the diagram, and that's why the diagram is provided for you. Make use of it. Use a pencil, just in case you go wrong, and you can rub it out and then start again, but use the diagram. Question 10. Write down the translation vector that maps A on to shape B. So if A is moving to B, let's pick this point here and think about how it moves to this point here. So it goes 1, 2, 3, 4 units to the right, and then 1, 2, 3 units down. So that means my vector is 4 minus 3. Do not put a fraction bar in your vector. You can lose marks for that. Do not write your vector as a coordinate, because the question specifically wants the translation vector. So this is the only correct answer. Do not write 4 units across and 3 units down, because again, the question asks for the vector. So the only way you're getting these 2 marks is to give the correct vector. Question 11. You're given the formula for the volume of a sphere here, which is very useful. A bowl is a hemisphere, so remember that's half of a sphere, and then the radius equals 12 centimetres. Water is poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds. Does the water fill more than 70% of the bowl? So the first thing I would do is work out the volume of the bowl. So to do this, we want to do 4/3 multiplied by pi multiplied by 12 cubed, and then we want to halve that. Or we could just do 2/3 times pi times 12 cubed, and that would give us the same answer. So this gives me 1152 pi. And I want to work out what 70% of this is. So that's going to be 0.7 multiplied by 1152 pi, 1152 pi. So if I multiply that by 0.7, and then I'm going to convert that into its decimal form. So 2533.380 ... centimetres cubed. So that's what 70% of the bowl is. Now let's figure out what's happening with the water. It's being poured into the bowl. So we have 325 centimetres cubed of water being poured into the bowl per second, and it's happening for 8 seconds. So if it's 325 centimetres cubed every second, we need to multiply that by 8 for 8 seconds. So that is 2,600 centimetres cubed that's being poured in over the 8-second period. And what we can say is 2,600 is very definitely greater than 2,533.380 ... the value we calculated before. And so the answer is yes, it does. And we must show this comparison to make that clear as to how we know, and we must say yes. And this is an area people often lose a mark on because they don't answer the actual question, and the question requires a yes or a no answer backed up with evidence. Question 12, there are a multitude of different ways of working out this question where you show that the two rectangles are similar. Quite a popular way was to work out the scale factor of enlargement by doing 8 divided by 5, and that works out to be 1.6, and then working it out for the length as well by doing 19.2 divided by 12, and if you do 19.2 divided by 12, it's also 1.6. So because the scale factors are the same for the lengths and the widths, the two triangles are similar. There are other ways of doing this question as well, which will get you the 2 marks. Question 13. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 4x over 3 tea bags per minute. So there are X boxes per hour, and there are 80 tea bags per box. So the total number of tea bags packed in 1 hour is going to be 80 tea bags multiplied by X boxes, because each box contains 80 tea bags. So in 1 hour, that's 80x tea bags that are packed. But the question wants to know how many tea bags are packed in a minute. So in an hour, there are 60 minutes. So in 1 minute, if we want to work out how many tea bags are packed in a minute, it's 80x, the total number of tea bags in an hour, divided by 60 minutes. So you get the number of tea bags per minute. And then if you simplify 80x over 60, well, 80 and 60 both divide by 20, which gives you 4x over 3. Question 14. A company has 123 employees. Information about their hourly rates of pay is shown in the table. The owner of the company uses the data to make 2 statements. 14 part A, show working that supports statement A. So in statement A it says over 30% of employees have an hourly rate that is more than £17. Now there are lots of different ways of doing this question, so this is not the only correct method, but it is a correct method. Now, more than £17. So the employees in these 2 categories earn more than £17, and then some of the employees in this category earn more than £17. So what we're going to do is we're going to assume that because you've got a group that goes from 14 to 20, and let's assume, well, we know that there are 32 people in that group from 14 to 20. So 17 is the midpoint of 14 to 20. So if you imagine, we've got 14 to 17 as being the lower half of the group, and then 17 to 20 as being the upper half of the group. Well, let's assume, because that's the only thing we can do here, that the 32 people are split evenly, with 16 of them earning between 14 to 17 pounds and 16 of them earning between 17 to 20 pounds. So what we'll do is we'll then take this 17 people who we're saying earn more than 17 pounds or between 17 and 20 pounds, these 15 people who earn 20 to 40 pounds, and these 10 people who earn 40 to 100 pounds, and that's a total of 16 plus 15 plus 10 people who we are saying earn more than £17. Now that comes to 41 people, And if we work out what that is as a percentage, well, it's 41 out of the 123 people in total. Multiply that by 100, and then that comes to 33.3 recurring percent, which is greater than 30%. That's not the only way of doing this question, but it is a good solid method. 14 part B, why might statement A not be true? There are lots of different ways of expressing why this might be, but correct answers could include, for example, all of the employees in that interval might actually earn less than £17. We don't know that it's split evenly 16 and 16. We've made a big assumption there. We don't know how much everybody in that group earns as well. So it could be the case that everyone actually earns 14, 15, £16. We just don't know. So we have to kind of get across the fact that we've made an assumption that half the employees in that group earn below £17 and the other half earn above £17. So a good way of expressing that is to say that actually it could be the case that all the employees in the second interval might earn less than £17. We just don't know. Right, to work out an estimate of the mean, this is where we need to use the midpoints of the groups. So, for the first group, the midpoint of that group is 12. So I could just set up a little column here. The second group, we've got a midpoint of 17. The third group, we've got a midpoint of 30. And the last group, we have a midpoint of 70. So thinking about how I've worked out those midpoints, for example, the midpoint of 40 and 100, I've done 40 plus 100 and then divided that by 2 to get a midpoint of 70. Now, I then need to do the midpoint multiplied by the frequency. So that means I need to do 12 multiplied by 66, 17 multiplied by 32, 30 multiplied by 15, 70 multiplied by 10. Now, I get from each of these calculations the following values: 792, 544, 450 and 700, and I need to add up all of those values and then divide that by 123 to get my estimate of the mean. So I need to do 792 plus 544 plus 450 plus 700 and then divide that by 123, and that comes to an answer of 20.211 ... and I mustn't round up my value to the nearest whole number. We shouldn't do that with the mean unless we're told to. And this is money as well, so I'm actually going to round my answer to £20.21. Part D, why is the mean not the best average to represent the data? There are lots of possible ways you can express a correct answer here. One possibility is the fact that actually the majority of people do not earn more than £20. And if you actually look at the data in the table, these people here all earn under £20. So that's 66 plus 32 people, which is 98 people. So that's more than half the people earn less than £20. So because more than half the people earn less than £20, or because less than half earn more than £20, the other way of putting that, it means that the mean isn't a good representative average. Now, there are other possible answers that are acceptable here, and if you want to know more detail, consult the mark scheme for other possibilities. Question 15. An expansion question, fairly straightforward. Just make sure we don't make any silly mistakes with this. So we've got 2x cubed, first of all, plus 5 x squared y. I always write the terms out with the variables in alphabetical order so that it makes it easier to collect them if necessary later. Minus 18x squared y for these two terms. And then for the final pair of terms, we've got minus 45xy squared. Now, these two terms are like terms. If you have a look at this, they're both x squared y terms, and we can collect them. So we've got 2x cubed minus 13x squared y minus 45xy y squared. Question 16. Line A has equation y equals ax minus 1, passes through this point, and line B has this equation. Show that line A has a greater gradient than line B. So this is the kind of question where we want to divide up our page so we can make our working very clear. And let's work with line A first of all. We have a coordinate which we can substitute in. So 13 equals 7a minus 1. So I've replaced y with 13 and I've replaced x with 7 using the coordinate that lies on the line A. And we can solve this mini equation. 14 equals 7a, a is equal to 2, which means that line A has the equation y equals 2x minus 1, which means its gradient is equal to 2. And if we can then work out the gradient of line B, we can compare the two gradients. Now, line B is not expressed in the y equals mx plus c format, so we want to convert it to the y equals mx plus c format. So I would start by adding 3x to both sides, so 5y equals 3x plus 4. And then I divide by 5, so y equals 3/5 x plus 4/5. So that tells me that the gradient of line B is 3/5 or 0.6. And so the gradient of A, which is 2, is greater than the gradient of B, which is 0.6. And we've shown what we are required to show. Question 17, work out the size of angle X. So there's a temptation to go in very hard on this question because it's question 17 and we're perhaps getting towards the last third of the paper. But it actually is a fairly simple standard trigonometry, SOHCAHTOA if you like, question. So I can't do much with the triangle ABC yet, so I'm going to have a look at this triangle over here. And I can label up 4 centimetres is the hypotenuse, this is the opposite because it's directly opposite angle 37, and this is the adjacent. So I want to work out the adjacent side because that's connected to triangle ABC. I've been given the hypotenuse and there's nothing much I can do with the opposite, so let's rule that out as being unhelpful to us for the moment. So if it's adjacent and a hypotenuse, it's cosine, ka. So some of you might write down your SOHCAHTOA, and again, adjacent and hypotenuse tells us it's cosine. So cos of 37 is equal to the adjacent divided by the hypotenuse. So cos 37 is equal to the adjacent, which is AC, divided by the hypotenuse, which is 4. So that tells me that the adjacent, or AC, this line here, is equal to 4 times the cosine of 37. And I can leave it as 4 times cos 37, or I can actually work out what 4 cos 37 is. It's 3.1945 ... Do not round at this point here. If you start rounding this down to 3.2 or even 3.19, your final answer is going to be inaccurate. So leave it there, and you can always just use the answer button on your calculator for the next part of the calculation, or write down 4 or 5 decimal places, and then you'll have enough accuracy for the next part. Now, moving on to triangle ABC. This time, this is no longer the adjacent, it's the opposite. And this is the hypotenuse. So this now becomes a sine question. And we can say that the sine of x is equal to the opposite divided by the hypotenuse. So sine of x is equal to AC over the hypotenuse of 9.3, but we know that AC is this number here. So sine x is equal to 3.1945 ... divided by 9.3, which tells me that sine x is equal to 0.343499 ... And if we use inverse sine and the answer key to help us, so x is equal to sine minus 1 of 0.343 ... That then gives us an answer of 20.0902 ... And I would round that to 20.1 degrees to 1 decimal place. Question 18. Rearrange y equals x plus 8 over x to make x the subject. So what we notice here is that x appears twice. So it's not going to be just a completely simple rearrangement. First step, let's get rid of the fraction multiplying by x. So xy is equal to x plus 8. Collect the x terms on the left-hand side. Xy minus x is equal to 8. And then our key here is to factorise. If we take x out, we've got y minus 1 in the brackets equals 8. And then divide by y minus 1, giving us x equals 8 over y minus 1. And let's write out the whole answer, including the part where it says x equals on the answer line. Question 19. Here are the first 4 terms of a quadratic sequence. Write down an expression, work out an expression for the nth term. There are so many different ways of doing this. This is just one method. It's not necessarily the best method. It is just a method for working out the nth term. There are reasons behind why this method works. I'm not going to go through them in this question because we're just looking at how to get to the right answer here. But there are good explanations that you can find elsewhere. Now, I'm going to work out the first layer of differences. So 3 to 20 is plus 17, 20 to 47 is plus 27, 47 to 84 is plus 37. So my first differences are as follows. Now, my second differences are obviously 10, and they're the same because this is a quadratic sequence, so we would expect that. Now, the nth term of my quadratic sequence takes a quadratic format, an squared plus bn plus c. And we can use this technique to work out what a, b, and c are equal to. So, the rule that I'm going to use is that this term here, 3, the first term in the sequence, is equal to a plus b plus c. This term here, 17, the first of the first differences, that is equal to 3a plus b. And again, it may not seem clear as to why that is, but there is an algebraic process behind this. I'm just not going to go through it in this particular video. And then the third rule that we're going to use is that the second difference, and the second differences are all the same, those are equal to 2a. So we've got 3 very simple simultaneous equations here. We call them 1, 2, and 3. They're very, very easy to solve. Equation 3 straight away tells us that a has got to equal 5. Equation 2 can then tell us, instead of 3a plus b, we've got 15 plus b equals 17. Subbing in a equals 5, so that tells us that b equals 2. And then for part 3, well, we know that a is 5, b is 2, and so that gives us c is equal to negative 4. So that tells me that I have my a, b, and c. So my nth term is 5n squared plus 2n minus 4. Question 20, all about circle theorems. Assume that S is the centre of the circle, work out the size of angle X. So angle X and 130 degrees are subtended by the same chord PR. The angle at the centre is double the angle at the circumference, so X is equal to 130 divided by 2, so X is 65 degrees. In fact, the centre of the circle is on PS, but not at S. What does that mean about the size of angle X? So I would draw on the diagram. So what we're saying is the centre might be somewhere like that. So it's on PS, but it's not at S, which means that this triangle would look like this, which means that this angle here would look like this. And you can just see visually that's going to be bigger than 130 degrees, which means if we get to the circumference, the angle here is half of this angle, but if this angle here is bigger than 130 degrees, then this angle here is going to be half of a number that's bigger than 130 degrees, so that's got to be bigger than 65 degrees. So the question asks us to tick the correct box, and the answer is it is greater than the answer to part A. Question 20, also circle theorems, part C. For a different circle, AB is a tangent at A and C and D are on the circumference of the circle. AC is equal to CD. So ACD is isosceles. Here is Simon's method to work out the size of angle Y. So Simon says angle ADC is 70 because of the alternate segment theorem. Therefore, Y is 70 because angle's in an isosceles triangle. Is he correct? No, he's not correct. Straight away, we should be able to see that he's not correct because he's used the alternate segment theorem incorrectly. The alternate segment theorem tells us if we have a tangent, which we do here, and if we have a chord, which we do here, the angle between the tangent and the chord is equal to the angle in the alternate segment subtended by that same chord, which is this angle over here. So no, he's wrong, as angle ACD equals 70 degrees. And that means that angle Y and this angle, well, they're the base angles of an isosceles triangle. So if this angle is 70 degrees, Y is equal to 180 minus 70 divided by 2, and that comes to 55 degrees. Question 21, a compound interest question. Morgana decides to put £500 into an account that pays compound interest. She wants to have at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest rate that she needs. So she's doing £500 multiplied by some percentage multiplier, we'll call it x, raised to the power 3 for 3 years, and that is getting us to at least £560. I'll put equals 560, so we'll get an answer that would get us to exactly 560, and then we just need to go a bit bigger with our answer to make sure we get more than 560. And remember, the question says work out to one decimal place. So I've simply got to solve this equation. So x cubed is going to equal 560 divided by 500, which comes to 1.12. And then x, which is my multiplier, is going to be the cube root of 1.12, which if we work out that cube root, it's 1.03849 ... So that's my percentage multiplier. Now, if that's my percentage multiplier, I need to work out what the actual percentage increase involved in that. And that comes from this part of the number. So if it's a 1.03849, that tells me it's a 3.849% increase each year. But remember, that's going to get me to exactly 560. So if I want it to be more than 560, I'm going to need to make that 3.9%, not 3.8%, because remember, the question wants our answer to one decimal place. Question 22, we have an iterative formula. Now, this is not a topic that we see all of the time in maths, so it's one that you need to go and revise very carefully. So the starting value is x1 equals 4. So to get x2, I need to put 4 in for where x is in this formula. So if we set that up on our calculators, we want to do 5 times our 4 squared minus 2 times 4 minus 3, and then we need to cube root all of that. That's going to give me my value of x2, and that comes to an answer of 4.10156 ... To get x3, I've got to take this value and I've then got to substitute that into the same iteration formula. So we use the answer we got and we would just repeat the calculation using this value. So if we substitute that in, and you can use the answer key carefully to do this, we get a value of, this time, 4.17764 ... That's x3. Now I've got to list my values here, and I'm going to do these to at least 2 decimal places. Less than that, and you're not going to show the accuracy that the examiners want to see. So I'm going to give my answers to 2 dp here. I could do 3 or 4 dp as well. Now, by continuing the iteration, show that the value of x is more than 4.25. So if I then work out, say, a couple of more iterations, so I simply repeat my calculation. I'm going to see that x4 is equal to 4.2341 ... and then x5 is equal to 4.2757 ... and then we get to x6, which is 4.3063 ... So you can see that these values are greater than 4.25. And there's only one mark here, so the examiner really just wants to see you continuing the iteration so that you get to a value that's greater than 4.25, which you do with x5 straight away. Right, question 23. There are 3 sets of number cards: set A, set B, and set C. And in a game, a player has 2 options. Option 1 is to pick 2 cards from set A, and option 2 is to pick 1 card from set B and then 1 card from set C. The cards are picked at random. The player wins if the total of their 2 cards is exactly 10. Okay, so which option gives a better chance of winning? So if we look at option 1, that's drawing 2 cards at random from set A. Now, the only way of getting a total of exactly 10 from set A is if we get a 5 and a 5. So that means we want the probability the first card is a 5 multiplied by the probability that the second card is also a 5. Now, the probability that the first card is a 5, well, there are 8 cards and 3 of them appear to be 5, so we're looking at a probability of 3 out of 8. Now, the second card also being a 5, well, if one of the 5s has already been taken out, we have 2 5s left to choose out of a total of 7. So this then gives us a probability of 6 over 56. And I'm just going to leave it as 6/56 for the moment, because we need to compare our probabilities at the end in order to work out which option gives us the better chance of winning. So we'll leave it like this. For the moment, we may need to simplify our fraction. In option 2, we pick 1 card from set B and 1 card from set C. And again, we're looking for a total of 10. But the numbers are a little bit different here. So we need to look at how do we get combinations of 10s. And looking at the numbers, the only way we can do this is with 4s and 6s. So what we want is for B to be a 4, and then for C to equal a 6, or we want B to equal a 6 and C to equal a 4, our choice of card. So if we look at the first one of these, the probability of B being a 4 and C being a 6, let's do that one first of all. Let's do this one second. So the first one, which I've highlighted in red, B being a 4. So there's only 1 card that's a 4 out of 7. And the probability of C being a 6, well, that's 1 out of 4. So that's 1/7 multiplied by 1/4, which is 1 over 28. And then this second possibility, B being a 6 and C being a 4, well, B being a 6 is 1 out of 7, again. There's only 1/6. And C being a 4, that's 1 out of 4. So that comes to 1/28 when you multiply. Now, to get the overall probability, we need to add these 2 together. So that's 1/28 plus 1/28 for option 2, which is 2 out of 28. Now, if we go back to option 1, that's 6/56, but 56 divided by 2 is 28. So if we simplify this fraction, that's actually 3/28. So the option 1 probability is 3/28. Option 2 is 2/28, and obviously 3/28 is bigger than 2/28, so option 1 gives us the better chance of winning. Question 24, error bounds. What we need to do is make sure we are clear on the error bounds for A and B, and then which bounds we're using to get the upper bound for 2a squared minus b squared. So I will start with A and B, and I will put together a little table that has the lower bound and the upper bound of each of these. So A is 65 to the nearest integer, which means its lower bound has got to be 64.5. Its upper bound is 65.5. Now, b is 30 to one significant figure, which means its lower bound is actually 25, because you're looking for the smallest number that to one significant figure would round to 30. Now, one significant figure means we look at the first significant digit, which is 2, go across to the next digit 5, and that would round that up to a 3, so it becomes 30. You can see that 24 wouldn't work, because if you look at the first significant number 2, then look at the second digit 4, that can't round that 2 up, so that would round down to 20. So the lower bound for b is 25, and then the upper bound is just 35. If you think about how this has to be evenly split, if that's b as 30 in the centre, if its lower bound is 25, there's a gap of 5 here, so there's got to be a gap that's equivalent size to the upper bound, so the upper bound is just 35. Now, if we want to work out the upper bound for this calculation, 2a squared minus b squared, we want to make the first part of this as big as possible. So we want to use the upper bound for a. So I want to make it 2 multiplied by 65.5 squared. But I'm trying to make the answer as big as possible. So I want to take away as small a value here as I can. So I use the lower bound for b here. So I do take away 25 squared, not the 35. We don't just automatically use the two upper bounds. We think about how do we make the answer as big as possible, and the answer comes out to 7,955.5. Question 25. Show that these two fractions simplify to this when added together. So we're adding algebraic fractions, x minus 5 over x minus 2, plus x plus 5 over x plus 2. We need them to have a common denominator. So we're going to give them both a denominator of x minus 2 multiplied by x plus 2. So what this means is we need to multiply both the numerator and denominator of the first fraction by x plus 2, and we need to multiply the numerator and denominator of the second fraction by x minus 2, and that way both fractions will have a denominator of x plus 2, x minus 2. So the first fraction becomes x minus 5 times x plus 2 over x minus 2 times x plus 2, and then the second fraction becomes x plus 5 times by x minus 2 all over x plus 2 multiplied by x minus 2. Now, because the two fractions have the same denominator, they can be written over one single denominator like this, and we then have to simplify this numerator and this numerator separately. So this first numerator here, if we expand the brackets, we've got x squared plus 2x minus 5x is minus 3x, minus 5 times 2 is minus 10, plus, and then this one here, x squared, it's green one, x squared minus 2x plus 5x is plus 3x, plus 5 minus 2 times by minus 2 is minus 10. We'll leave the denominator just for a second. Now, collecting like terms here, we've got x squared, add x squared, which gives me 2x squared. Now, this part here, minus 3x and plus 3x will cancel out, but I've got a minus 10 and a minus 10, which gives me a minus 20. And then in the denominator, if I expand the double brackets there, we've got a difference of 2 squared, x squared plus 2x minus 2x, which cancels, x squared minus 4. And so we've got our answer in this format here, where a is clearly equal to 2 and b is clearly equal to negative 20. Question 26. We've got a question on transformations of graphs. The minimum point of y equals x squared is at 0, 0. The minimum point of x squared, y equals x squared plus 2. So this is a translation with a vector 0, 2, i.e. the graph is moving 2 units up, which means this turning point will move 2 units up and it will move up to 0, 2. The graph y equals x squared is reflected in the x-axis. So if that's the x-axis, then there's the reflection. It's going to look like that. So the new equation is y equals negative x squared. And 26 part C, y equals x squared is now transformed to give this function here. Well, this is an fx plus 3 type of transformation inside the brackets. It's a translation. And remember, it does the opposite to what you think it's sort of going to do with the sign here. It's a translation with a vector minus 3, 0. You must use the term translation here to get 1 mark, and you must give the correct vector here to get the second mark.